This is going to be important for the solutions unit, the one after the next one, and in grade 12. So when you have double displacement, that's fine. To write a total and net ionic equation, you should really have a reaction that occurs, okay? Technically, you could do it for one that doesn't, but then you would cross everything out, so that seems silly. But what we are actually trying to show with a net or total ionic equation is how does the solid form. You can do this for single displacement, so then it's basically getting rid of, for when we did the computer activity, getting rid of the nitrate ions and only considering the ions that actually switch. So when you did the activity where you kind of had to draw the molecular reactions that were going on, and it even said we are not going to show the nitrates because, or if you did the acid one, the Cl, because that's not, they come to the event but they don't participate. So we call those spectator ions. Just like a spectator is just there to watch the event, they don't participate. So they are not involved in the reaction, so they stay aqueous on both sides. So then if something isn't changing, then that's not a chemical reaction, right? They're in there, but they are not actually participating in the reaction. So here we have silver nitrate, so any nitrate is aqueous. Sodium chloride, table salt, aqueous, makes sodium nitrate, so now we have an alkali metal, aqueous, nitrate, aqueous, and then silver chloride is the solid, like you guys, that white solid that you guys made yesterday. So sodium here is an aqueous ion, as it is here, doesn't change. Nitrate here, aqueous, doesn't change. So we call those spectator ions, and you'll know that they're spectator ions because they're aqueous on both sides. If it doesn't make sense to just say both sides, I mean both sides of the arrow, like the reactant side and the product side, or the left side, right side, that's fine too. Okay. So we're going to do total first. So a total ionic equation is going to break apart all of the aqueous substances. But since a solid, you can see that's together, it's plus minus together, then that means that we are not going to break it apart. So what we're trying to do is really show what's happening. Aqueous technically means that something is dissociated in water. So if you have an aqueous solution of silver nitrate, then there is no silver nitrate in the beaker. It's silver ions and nitrate ions. Together like this is actually kind of misleading, okay? So we would, if you were asked to write the total ionic equation, we would split apart this. We would split apart this. This. Do we split apart the solid? No. So this is a continuation of what we did before. You have to figure out what the solid is first. Let's say you guess and you're like, I'm not sure. If you make one of them solid, then just carry your mistake through correctly. You'll lose a little bit of marks, but then if you do this, as long as you carry your mistake through, you chose the wrong solid, whatever. Write the total ionic equation for the solid you picked and the net one, and then you won't lose marks again and again and again, okay? So just because I am going to switch, I wrote the equation again, but you guys can see it on your sheet there. So it's up to you if you want to write it again. Okay, so on the next slide, yours starts at using the previous example. It doesn't have the equation again because for you, it's right there. So it's up to you if you want to rewrite it, okay? So when you do a total ionic equation, and the net ionic, it can be a little bit tricky, okay? What's important is that if something is aqueous or solid, those items are important. But you technically, if something is aqueous or it's an ion, that means it has a charge. So for example, when we are going to split apart this and write silver as its ion, so right now it says it's aqueous, okay? It technically doesn't say the charge. So you would have to uncross or go look up what silver was. You should write that silver has a charge of 1. Does the charge affect the balancing? No, right? So sometimes people are like, Miss Todd, I can't figure it out. I don't know how to uncross. There's already so much going on here. I don't know how to write the charge. So usually in grade 11, I say, if you can't figure out the charge, don't worry about it. But what's important is the states, okay? You must have aqueous and solid, okay? But if you don't have the charge, that's okay. So I'm going to write them in. It does start to get a little bit hairy, okay? But the charge is just emphasizing it's an ion. Ions have charge, but it doesn't affect the balancing. It doesn't affect the number of atoms. So it can be a little bit, at first when you first do this, you're like, this is so annoying. I don't want to, it messes me up. I get it, okay? So now we're going to keep going. Nitrate is on the back of the periodic table. You could just go look up its charge, but it's okay if you don't. Sodium and chloride are aqueous. Those ones you could count their column on the periodic table. Okay, and then we have sodium nitrate on the product side. It's also aqueous. But then silver chloride is not. So we keep it together. The solid is solid, plus minus, together. And so what we have here, we have the formation of the solid, but we also have spectator ions. So just like say you have a job and you make 15 bucks an hour and you work for 10 hours. So 10 times 15 is $150. Is that what goes in your bank account? No. There's taxes, maybe you have to pay union dues, whatever, right? So your net pay is really the money that you have available to spend. So a net ionic equation in a chemistry sense is really just showing where is the chemistry action, where is the reaction. So the net ionic equation shows the ions involved in the chemical change. How do you know what those are? The ones that make up the solid, okay? Another thing that you can do is cross out spectator ions. When you do these kinds of questions, usually it's like part A, write the word equation. Part B, switch the partners, figure out the solid. Part C, write the total. Part D, write the net. So I want to see your total, okay? So if you're going to cross out spectator ions, that's fine, but just do it lightly, okay? So that I can see what's underneath. Some people choose to not even cross them out. They just like cross them out in their brains, whatever. So you have a variety of options to do here. You can just take a look and say, okay, well, if silver chloride is the solid, then the ions are silver and chlorine. Or you can take a look at the ions that are not changing. So whenever we have something on the reactant side that's the same as what it is on the product, we can cross it out. And we're even going to do that in grade 12 too. Okay? So here, nitrate aqueous. Across the arrow, nitrate aqueous. It hasn't changed, so lightly cross her out. Sodium, aqueous here, aqueous across the arrow, cross it out. So then when you write the net ionic equation, now you can see, once you've crossed stuff out as well, then all we have left is silver ions. Chloride ions make the solid. So you have two choices really. You can do what's the solid and then go and write the reactants as the ions, or cross out the spectator and write what's left over. So we have silver plus chloride makes silver chloride. And once it's balanced, it should be balanced the whole way through as well. So again, if you screw up the balancing, just keep what you have. Okay? So now let's do another example. So we'll go all the way from the beginning. Again, I made it really tiny so I could fit it all on there. I apologize. So complete the reaction for barium sulfide, sodium sulfate. We're going to write the word equation. We're going to balance it, including the states. We're going to figure out where the solid is. We're going to do the total. We're going to do the net and write the spectator ions. So similar to this morning, if you want to put them, write it like barium and then sulfide underneath so then you can see what switches. It's up to you. If you wrote it down before I started and you wrote barium sulfate first, that also doesn't matter. And similar to this morning, you can decide for yourself now. I like the words. I'm going to go use the words to figure out which one's the solid. It doesn't matter. So again, try to think about it logically. Does it make any sense for me to give you one that's going to be no reaction if I ask you to do the total net and the spectator? No, that right? I would never do that. So make sure that one of them is going to be a solid, okay? So similar, as we've been going along, you decide how much work you need to show. So barium is a transition metal. I mean, not a transition metal, sorry. an alkali earth metal, so it's 2 plus. Sulfur's in the same column as oxygen, so it's 2 minus. Sodium is an alkali metal, and then sulfate. So again, you might say, Ms. Todd, you have sulfate in every single example. Why? That's practical. Sulfate is a very common ion, okay? So now, even if you choose to just show, like write them out like this, then when you go to make the products, when you have to recross, then you can see where the charges are, so it helps you out to do the products, whatever, whatever makes you successful, okay? So now we've got, when these two cross, we're going to reduce. Again, the reactants for double displacement have to be aqueous, so you can trust me or you can go check. Sulfide plus, which is row 10. Sulfide plus alkali ions, alkali earth ions. Oh, there's barium. And again, if you forget, it says at the bottom of our periodic table, okay? Is soluble. Sodium and sulfate. So this time when you cross, the 2 is going to go down here. So we have number 9, row 9 is sulfate, or the first one. Maybe now you're like, okay, if I see an alkali ion, I know it's soluble. Which will help us here. Alkali ions are soluble. Sodium sulfide, it's going to be the soluble one. And you've got sodium here, sulfide here, so you can just now cross them. Same thing with barium is 2 and sulfate is 2. So you decide, are you a bracket person? Technically you don't need them here, but you can put them in. So logically in your head you should be thinking, okay, when I go check for this, probably, or no, not probably, I should get barium sulfate as the solid. Let's go check it out. Row 9, calcium plus, or sulfate plus calcium, strontium. Oh, there it is right there. Barium is insoluble. Okay, only one solid. If you're asked to do the rest of them, the chances are you're not going to be given a no reaction. Okay? That seems unnecessarily cruel. Do we need to balance this? I think it's balanced. But we should check. Barium 1, barium 1, yes. Sulfide 1, sulfide 1, yes. Sodium 2, yes. Sulfate 1, sulfate 1, yes. So always check. It actually really doesn't matter if you're like, you know what, I'm so good at net, and you do the net one first and then go back and do the total. It really doesn't matter. But if you are the kind of person who likes to cross stuff out or eliminate what you don't need, then definitely you want to write the total ionic equation first. Split apart all aqueous. And I apologize if my writing's small. This does take up a little bit of geography on your page, okay? So we have barium and sulfur are aqueous. When you show what the ions are, that's also helpful to do this because it's going to be the same. You needed to know the charge to do crisscross. That's going to be the same thing. Barium, sulfur, or sulfide, sodium. But now here, how many sodiums do we have? Yes, 2. So if you write it like this, that's sort of nasty because then it looks like it's diatomic, which it's not, right? So the way that we do that, we write, I'm going to use a different color. We write it as a coefficient. okay? So then it doesn't look diatomic, okay? Thank you. Okay? So now on the product side, same thing. You don't need to write the coefficients a different color, but I'm just trying to emphasize it, okay? So I'll do the same thing here. We have 2 sodiums. And if you want, write the, whatever this is, the solid in a different color too. And I have to squish. Sorry. Do not split apart the solid, okay? So for the net, cross out the spectator, or just show the solid, use the ions to show the solid forming. You have some choice. But again, please, you're going to get marks for this. So make sure if you are a crosser that you don't like annihilate it so that I can't tell what was written, okay? So what ions are aqueous on both sides? Sulfide, aqueous, aqueous. Sodium, of course, aqueous, aqueous. Right, the spectator ions, so these are the ions that you've crossed out, or the ones that are aqueous on both sides if you're not a crosser. Okay, you can write them in words, or you can just write the symbol. Also, that doesn't matter. So it's going to be sulfide and sodium. So you should have 2 ions that make the solid, and then the other 2 ions that make the spectators for double displacement. In the homeworks, the textbook wants you to do net and total for single displacement as well. So single means there'll be 1 spectator, okay? Similar to what you guys did this morning, where the nitrate wasn't included, that was the spectator. So this is the same as what we did this morning, and this we're just now kind of applying it, okay? So now you can do the whole test review. Remember, the front is the questions and the back is the answers, okay? Tomorrow we're going to do a liturgy and then a lab, which is going to be super fun. And then we'll do review, okay?